Namo Namaha. Sarvebhya Namaskaraha. Suprabhatam. Let us start the second month of our coursework. We have already finished 1 month, and now this is the second month. The first topic in this month is Vedic mathematics by Gautam ji. You all know Gautam ji. And now we'll start with Vande Mataram by C.C. Babu Garu. Request all of you to stand up and sing Vande Mataram.
Let's start.
Yeah.
Vande Mataram. Vande Mataram. Sujalam Sufalam Malayajasi Talam Sasya Syamalam Mataram Vande Mataram Suprajyoshna Pulakitayaminim Pullakusumita Drumadala Sobhinim Suhasinim Sumadhura Bhashinim Sukhadam Varadam Mataram Vande Mataram Vande Mataram Vande Mataram. Namaskar.
Dhanyavadaha, C.C. Babu Garu. Now we will have, we will do Prarthana. You are on mute.
Dhyanam, 1 minute. ध्यान समये गणपतिं सरस्वतीं चिन्तयन्तु. शुक्लांबरधरं विष्णुं शशिवर्णं चतुर्भुजं प्रसन्नवदनं ध्यायेत् सर्वविघ्नोपशान्तये. सरस्वती नमस्तुभ्यं वरदे कामरूपिणि विद्यारम्भं करिष्यामि सिद्धिर्भवतु मे सदा. असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतंगमय. ओम शांति शांति शांति. मातृदेवो भव पितृदेवो भव आचार्य देवो भव अतिथिदेवो भव. ओम गुरुर्ब्रह्मा गुरुर्विष्णु गुरुर्देवो महेश्वरः गुरुस्साक्षात् परं ब्रह्म तस्मै श्री गुरवे नमः. हरिः ओम. नमस्कारः. सर्वेभ्यः स्वागतम्.
Okay, Dhanyavadaha. Now I request Lalita ji to introduce. He doesn't need any introduction, but nevertheless, we will go with our procedure. I request Lalita ji to introduce Gautam ji to all of us.
Good morning, Sarvebhyaha Namaskaraha, Shubhodayam to all. Today, that is the second month of our Sanaatana Dharma course. On the starting day, we have with us our regular, who has been a regular student, and also who is our speaker from today, special speaker, Sri Gautam Mukherjee ji. He is such a prolific, you all would have noticed that the way he raises questions and all, it's all that it shows that he's a Sanaatana Dharmi. Basically, he's a favorite of Sanaatana Dharma. And also, to coming to his academics, I think he's from West Bengal, he's a Bengali. And he has his academics from Burdwan University in the year 1977. He completed his master's in physics. Then he had his PhD done from the IIT Kanpur in the year 1986. And from 1990 onwards, he's been working for National Informatics Center. And he retired as a senior technical director in the year 2016. But overall, whatever was his academics or his profession, is always remained a Sanaatana Dharmi. And he's a follower. And his passion is Vedic mathematics, which he is going to really take us all through for the coming 3 or 4 days. And let's all be prepared. We welcome him on behalf of Veda Samskruti Samiti and all our Sanaatana Dharma students and ourselves to have a wonderful Vedic mathematics session where we all have to be ready with a book, pen, eraser, whatnot. Everything has been already prescribed. And Karnalji already informed all of us on 1st June itself what all we need to be prepared for these classes. It's going to be a classroom for us where we'll be sitting with our pens and books. Let's all again welcome him. And I request Gautam ji to take over and start his session. We all are excited to be part of the session. Okay, sir. Welcome, sir.
Dhanyavad. Thank you. Visible? Screen visible?
No, not visible.
A little dark. It should be a little more this one. I think. It's some bright light is there.
No. What I'm telling that my screen is visible or not?
Your presentation is not visible. Not even screen. You are only visible now. You present it, na?
Achha, share screen. Achha, yes. Now?
Yes.
It has come, yes. Slideshow and from current slide. It is not showing the slide actually.
It is showing the slide.
It is showing, but this is not actually proper view of this. I don't know why it is not going to that view.
Or you want to have big, make it bigger?
Right. Anyway, with this can do, but it will, this is very peculiar that it didn't come. So, if I include this introduction to Vedic mathematics, now I don't know what is happening. So this cannot be rehearsed unless it's properly in room. It is got rehearsed actually. This is the problem. Why not showing? That day it was showing slideshow. Resume slideshow. It's now it has come now. Yeah. So introduction to Vedic mathematics. Now origin of the counting and mathematics. Do you hear me?
We hear you.
Okay, thank you. Origin and counting of mathematics. See, ancient people use just a line to keep track of various items. Suppose some ships are going. Somebody will put a dot in that in a line on the grass, on the ground or something with a stick or something like that. With that, the concept of counting came. Or you can say that from the fingers 1, 2, 3, 4 up to 10, people can count by showing fingers. So that is the origin of that. And then somebody put that to count, make it easy. They puts that after 4 lines, if they cross it, so that it becomes 5. And that way it came. Now Babylonians used they used this 10, 100, different symbols are there. And you know, Roman's number still all of us know, and it is already in use. That there are few symbols, 7 symbols are there. Say I, V, and so on. This for 1, 5, 10, 100, 50, etc. And then they used to have this additive in nature. And example is given in D is C is written after D, so it becomes D is 500. This is 100, so it becomes 600, and then again LX it becomes 60, and then VI is 66. But if we reverse that with each of the pairs, see CD becomes 4, XL become X is less than L. So if I put that 10 before L, 150, that becomes 40. So it is 444, like that. And still these are used as an ordinal number. That means ordinal number for something to do with cardinal and ordinal numbers. What are cardinal and ordinal numbers? Those are actually this normal number that we add, subtract, and so on. Those are called the cardinal numbers. Whereas ordinal numbers are showing something like the first, second, third, fourth, etc. All the mathematical calculations can be done only on ordinal numbers. On cardinal numbers. Whereas ordinal numbers means these are actually because normally all this TH and RD are not given all the time, but as you know, roll numbers, pins, others, they have no meaning of adding to say postal index number, pins, or here also pin is there. There is no meaning of adding two pins and say 2 other numbers. There is no meaning of that. So those are actually called ordinal numbers, which just a position can be seen, can be used. Now, the actual current, particular system, what is called positional number system or the place value system, is actually, it has origin in India. Sometimes people tell that what is the contribution of India in mathematics? People will say, all will say that it is 0. The invention of 0 was the contribution of India, but it's not. 0 is, in my opinion, 0 is just a corollary of the thing. Actually, what is the contribution of India was this place value system itself. That is the basis of all mathematics in thereafter. So, and the history that I read from some book, that is from 6th century, 7th century onwards, it is that particular idea spread to Europe, but it came through Arab. So therefore, these are called Arabic numbers. That is actually a misnomer. They are actually wrongly it is called Arabic number system, but it's actually not. Now, this how it is? No, that is decimal system are used, and 1 to 9 was used recently. And there is, when there is no value in that particular place, a heavy dot, a big dot used to be, big dot or a hollow circle used to be put there. So that is the invention of 0. That is the only corollary. So that if no digit is there, a particular place, say there is no 100 there. So put in the 100th place, we put a instead of putting a gap, put a big circle, and that is called zero. So this is about place value system. Now, various symbols for 1, 2, 3, 4, these are used in the number systems in India. You know, have Hindi, Bengali, Punjabi, Gujarati, all these things have. Telugu is there. You know, did I collect it correctly? The Telugu symbols. Telugu symbols, did I get correctly? Is it?
Sorry, what do you want to say?
This Telugu symbols still are in use, and it is sorry, you collected it correctly.
Telugu 0. No. I can go on. 1, 2, 3, 4. Yes, they're all okay.
These are okay, no? Any other number, you know? This, for example, I can see my Bengali are okay. Already,
you want to interact with the audience?
Yeah.
I'll allow them to unmute, but I request all participants, the moment you speak, please mute. Don't keep it unmute state.
So, anybody, any reaction? Please tell me that whether you get your own, see your own language here. Somebody from Gujarati or Punjabi, Bengali.
Tamil and Kannada can be seen. For me, Telugu, Tamil, Kannada, and Malayalam, I am able to see these languages.
I mean, you know the symbols, no?
Yeah, I know the symbols. English.
These are familiar to you.
Tamil, Telugu, Kannada, Malayalam, 4 South Indian languages I am able to see.
Yeah. And anybody says knows about Punjabi and Gujarati, Odia, these are also coming all right. Actually, these I collected in Excel. You know, actually there is a Unicode framework is there, and the Unicode framework is, it says that this is 966. It will be 0. This, for example, you want to do this Tamil, this one. Tamil, it is actually 5. 0, 1, 2, 3, 4. Yes, Tamil 5 is this one 5. Now you want to write it on your MS Word. So you have to write BE, and then you write B here. The third digit. The first 2 digits are BE for Tamil, and the for 5 of the B, 5, this is B. So you write BEB and put Alt and X. So it will immediately display this particular symbol. So that is the thing. So you can know that that is the idea of this coding of this. Actually, whatever is there in used in today's all the languages in the world and so on, these are all called Unicode framework. Unicode. So the Unicode actually consists of 4 set digits. In our case, all the Indian languages, this first digit is 0. So it's basically 0966 is the 0 for Hindi. So we can come back to concept if somebody wants to verify. Now, this concept of base, so I come from that, the concept of base in the place value system. So normally, by default, it is 10. I mean, 10 was used because it is according to human hand, it is called. 10 was used as a decimal number system. Now, there is actually, so these places are called unit, 10, 100, 1000, different powers of 10. Likewise, suppose base is there in computers, most convenient to start with is binary system, and base is 2. And when these are grouped in 3, so base becomes 8, and when this binary is grouped according to 4, so it becomes hexadecimal. So these are also used in computer. This is some actually for the easiness of ease of use, these are used. The binary becomes very long. So hexadecimal, for example, is very commonly used now. And as I the last slide I told that hexadecimal, Punjabi A6 0A69 will become the 3 of the Punjabi, for example. I read this told this example. These are called hexadecimal. So decimal we will be stick in this particular presentation. We will be obviously normal our number system, which is called decimal number system. Now I come to basic mathematics. What is basic mathematics? It is the intuitional use of 16 Vedic sutras or formula and 32 sub-sutras, corollaries they are called. That are only 13 are used out of that. It is from the Vedas. So it is from actually Atharva Veda, and the first speaker, Mr. Shiva Kumar, what is his name? So he told that it is from some kalpa. I exactly didn't get, but some kalpa of Atharva Veda. So it is actually used. Why it is used for tackling the different mathematical problem? I mean, addition, subtraction, multiplication, division, and so on. Square root. Basic mathematics is a collection of various alternative methods in solving any mathematical problem. So, as you know that from the time when our Sanskrit teaching was stopped by Englishmen, and so they stopped all our texts also, including basic mathematics. So people could not know that what is actually general public, and that in the teaching front, these are not taught. Only the particular addition, mathematics, addition, subtraction, and so on, these are taught. And we thought that it is the only way. So from our childhood, we kept on knowing only one particular way. So that is what we know, that normal addition, subtraction, multiplication, division. But the basic mathematics gives us the alternative. Maybe that prior to this English coming here, maybe those all were in proper use, or quite good use. But after that, it was stopped. It aims in developing mathematical intuition. Means that, see, you know that I tell you that the people who discovered this something like place value system, it is a revolutionary idea at that time. That the place value itself is a revolutionary idea, and people who can those rishis, basically those are rishis, the rishis who invented the place value system. We should not believe that they left it at that position only. They must have done much more than that by developing various procedure, and they are very much intuitionally connected with all the number system. So that basic mathematics gives us that intuition, totally with which we can have that best use of the number system in terms of any mathematical problem. And then in any particular given problem, we have a choice. Not only one, cannot stick to the only one choice, but we can intuitionally we can immediately switch over to a particular procedure by which it becomes the easiest way for that particular problem. So it is also it is a procedure of mental development in parallel to solving mathematical problem. That is the idea of the basic mathematics. In Veda and our Sanaatana Dharma, anything is targeted towards human development after all. So it is a basic mathematics. It's not only from problem solving in mathematics, but it's also a part of human development. This is very to be honest. Now these sutras I read out. So as you see, these are all collected from a particular book. I explain that book as Bharati Vishnu Tirtha. So thing like this sutras are ekadhikana purveka. I'll also come to the meaning. It is one more than the previous. So that way, there are so many meanings. In the next slides, I will give you. Nikhilang namatas charamang dasata. You subtract everything from 9. Nikhilang, all from navataha means from 9, and only charamang, the ultimate one, last one in that sequence, from 10. Dasataha. And urdho tirjagabham. That means in the upper row, you go in a slant cross way, tirjag. So there is so many that one. Some of them we will see our in our presentation, but all of them maybe and may not be I have seen. Charanam Kalamabhyam in the 9th, and so you can see that all these things are there. With this, time to time we will refer to these formulae, and we'll understand that what is the application of all these things. And each of them can be applied in various ways. Some of them can be applied, say, it can be in the in case of recurring decimal, we'll find this application. Nikhilang Navatasya, it is actually used in multiplication, in addition, multiplication, division, all these things are there. Urdhati Jagabham, it is used in multiplication. We'll see all these things. 16 sutras, then come to 13 sub-sutras. So these 13 sub-sutras, Unurupeno, Sishate, Sesasam, and these all are like this. Restanam, and Vilakanam, observation, and so on. So this is the Vedic mathematics book, which is very good on, quite cheap also. It's around 200 rupees. One can order in through Amazon and find all these very good discussion about Vedic mathematics. Bharati Krishna ji. He was one of the Shankaracharya actually of Puri. Now Vedic Sutras, some meaning in English I describe here. Ekadikana Purvana means one more than the previous. Nikhilang Navatas Charamang Dasata is all from 9 and ultimate from 10. Urdhva Tirjagabhavam means with upper strand. Paravartaya Jojayat means transpose and apply. Shunnam Samma Samuchate. A common factor is the same, which is 0. Like this one, this week, or these are with whatever we could collect. I write here that this English meaning of that. But Sanskrit experts are there. If they can tell me that if anything is wrong, or actually my pronunciation in Sanskrit may not be that good actually. Sankalana Bekalanam means that by addition and by subtraction. Purana or Puranabhyam by completion or non-completion. This way it goes actually. Chalana Kalan, many the actual differentiation, integration, all are there actually. Colon means actually differentiation. Sequential motion differentiation. Javadana. In this particular session, actually, these together, if we want to teach it, it may take much more than what is allotted in this particular session. Sorry. Sometimes in the advanced stage, we may have later this thing, but whatever I in this particular the reaction of the audience and according to the learning capability and easiness, we'll proceed. Let us see how much we can do it, and so we have prepared all these things. So we can come back again and sometimes after learning some of them. And now the scope of Vedic mathematics. As I told you, this can do arithmetic computation, multiplication, division, factorization. It can do also algebra. I didn't write it here. Equations. Highest common factors, both for arithmetically and for algebraic expressions also. All these things can be done. Equations, divisibility. As you know that we divisibility with 3, 9, 11 we learn from our childhood, but divisibility by 7, 13, those are ignored. So what is the general way of divisibility? This will be taught here. Recurring decimals and integration. These are all impossible, but integration, as I told, it's not in India and here. Arithmetical computation. The rules of addition, subtraction, multiplication, and division, which are commonly taught in schools, all have some other algebraic background. Only things that we not always consider them, but actually all those procedures are algebraic background is there. So why during multiplication we first unit digit we multiply, then we shift the one position we shift towards left. That is because you are multiplying by 10 basically. So these are algebraically all related. But people, the children learn from this from childhood without knowing the algebra behind that. But those all are connected algebra. But if the inherent algebra is changed, new methods, the procedure will be changed. Method will be changed. That we will see. Only that the different algebra if you use, accordingly there will be a particular procedure. That is the in basic mathematics. That is that kind of thing. In mathematics, basic mathematics, in a particular place, what is called this unit, 10, 100, these are called place positions, places, and the value that occupies in that place in our normal mathematics, it can be either 0 or a positive one, up to 0 and up to 1 to 9. It means basically 0 to 9. But in basic mathematics, negative values are also used, and negative values are as easily used as our positive values. It is why, because it is told that you do not have to remember more than 5 by 5 table. Whenever there is something more than 5, say 48 here, more than 548, so immediately you can express it as 5 and 2 with a bar in the top. So it should have been like this, I tell you. Let me see, I can show you or not. It should have been like this. Like this. Oh, sorry, it's not doing. I have to write my mouse. Like this. So here actually I could not find any way to put it is below, put below, put on the top. So you have put it on the put on the as underline. So underline whenever you see that, you have to understand that is actually vinculum. This particular notation is called vinculum notation, and you will be covering it in the next slide. Concept of vinculum. In number with a bar above is called vinculum. Vinculum notation in Vedic mathematics. They denote negative numbers. Because of technical difficulty, as I told, in the writing bar above in this presentation, we will use as an underline. So actually, basically, this means -2, 2 bar. Actually, it should have been top. So general number conversion and vinculum number and vice versa. 6 is equal to 10 minus 4. So vinculum notation of 6 can be, as I told you, if it is more than 6, more than 5, you can always put it as a vinculum. So it becomes 1 and 4 vinculum. 97, it is 100 minus 3, it is 1, 0 and 3 vinculum. 143 and conversion I have told you, say number is 142857. So we write 143 and again 143 in the in vinculum. 289. So 300 minus 11. So you write 3 and 11, 1, both are vinculum. Like this. So this sutras, Nikhilam Navatas Charamadasutta. See here, say I take example of this 143. So see 3 is subtracted from 10. So we get 7. Whereas 4 is subtracted from 9, not 10. So Nikhilam Navata from 9. So 4 is subtracted from 9, so becomes 5, and 8 is subtracted, or 1 is subtracted from 8. So whenever in a particular set, it can be also multiple vinculum can be there. In all kind of vinculum and conversion, you have to remember this formula, that Nikhilam Navatas and Charamam Dasata. And Ekanunana Purveno in this case, because 143 it becomes 3 becomes 2. So the end of vinculum, just before that, when you are converting from vinculum to proper number, this 3 will be the last one. Purbeno, vinculum, the earlier to vinculum will be reduced by 1. So it is 3 is reduced to 2. So is it clear? I want some reaction actually from.
Yes, it's
Any-
clear.
It
Yeah.
is.
Any question?
There's no question. I mean, we are able to understand. Yeah.
Anyone need further clarification about the vinculum notation?
Sir, why we used only -4? Why can't we use some other letters? The vinculum at 6 is equal to 10 minus 4. Instead of that, we can use some other thing also, no?
No, as I told, that idea of vinculum to reduce to or values reduced to always 5 or less. So 5 or less, that is the idea. So,
But in 300, it is 11.
where? Oh, no. See, it was 289. 8 and 9 was more than 5. So what I did? I did 300 minus 11. So that becomes 3 and 1, 1 with vinculum.
Oh.
So that the 8 and 9, instead of 8 and 9, I have to handle this 1 and 1.
Oh.
See here,
Difficult.
3, 8, 6, 7, 5, 6.
Okay.
I did it opposite. It should have been. This was vinculum on this has not used. Suppose it had been 3, 1, 3, 2, 4, 4. I'll correct it. So no problem. We can do it. But here it is opposite. Already it was 2, 1, 3, 2, 4, 4. Here we don't have to do vinculum in this case. 2, 1, 3, 2, 4, 4 is all are small numbers. So it's just example actually. So here this is 1, 4, 2, 8, 5, 7. 8, 5, 7 are 8, 5, and 7 are comparatively bigger number. So we express it 1, 4, 3 and 1, 4, 3 vinculum like this. So I'll come again. In all the problems we will be keeping you. Any other question? Should we proceed?
So what is the advantage of having this vinculum number?
As I told, it gives you the advantage of using only up to 5, 1, 2, 3, 4, and 5, not more than 5. So in all subtraction and multiplication and division, all these things where you will find these applications. I'll give an example. The next one you'll see it. Vinculum is applied to reduce the effort of calculation. Expert and intelligent use of vinculum. So one becomes expert, so you don't have to always subtract from 9. You know that 4 means 5, 3 means 6, and vice versa. 2 means 7. When coming to that, prior to the in Nikhila Navasas. Otherwise, in the Charama, last one, it is 4 and 6 pair will be there, 5 and 5. 5 has no meaning there. 7 will be 3 and so on. So like this one. That one, it becomes automatic. Something like that. One becomes expert in vinculum. It will be very much. You'll be expert in many things in the further. Here an example is given for addition. How the Nikhilam Sutra and vinculum is used for the digits in the addends are more than or less than equal to 5. It is easier to add vinculum and find it. Oh no, it is greater than 5. I should have. I can correct it. Okay. It is greater than 5. Vinculums are used. Finally, convert the resultant vinculum into actual number. Example. See, we are going to add 9, 6, 7, 8, 9, 6, 7, 6, 8, 9, 8, 5, 6, 7, and 7, 5, 8, 9, 8. what we do normally, normal procedure, we use 8, 9, 17, 7, 7, so many big numbers, and finally arrive to this number, 30,530. So see application of vinculum. Immediately this 9678 will be 1 and 0322 in vinculum, and these all will be reduced like this, all small numbers. And we just adding these small numbers will be much easier. There can be carry also, but it will be much easier. So finally, this will be all non-vincular number. So we'll arrive with this result. The expression, what is going on behind this is like this. So in vinculum, it becomes automatic. Don't have to express like this. It becomes actually 10,000 minus this, and it is 40,000 minus this much. Which is this? Background, this process is going on, this algebra, but here we are automatically, people who will practice the vinculum will become so expert that even before somebody, we can as a demo, we can have competition between two students who use this formula, and one is expert in vinculum and use this one. I think it will be much faster in that. And sometimes what will happen, I didn't put that example, I can prepare that. There will be a mixture of small and big numbers. Here also it will be non-vinculum and vinculum numbers. And this negative and positive, they will cancel sometimes. It happens that had it been, say, 3, I could have written here positive 3. And this negative 3 and 3 would have cancelled. So we'll always come to a stage where it will be, effort will be reduced to a much extent. We'll see. Any reaction is the concept here? For the people?
Yeah, we are slowly able to understand.
But you find that it is beneficial?
Yes. I mean, the only thing is we'll have to practice, and then only we'll
practice. Yes.
Yeah.
So, in my
One second, Madhay. Yagesh ji, you wanted to ask something.
yes, sure, please.
So sorry, I might have missed if you have already told this, but
There's no problem. I can repeat. I do not see you. Can you show your video?
yes, sir, my video is on. Oh, I'm sorry. 1 second. Yeah. Yes, sir.
Yes, I see you. Yes. Please tell me.
The thing is that when okay, so the notation is clear that and this thing also that I mean, if it is less than or equal to, I mean, we have to keep it less than or equal to 5 to keep it easy. But suppose for this example 9678, we are writing it as 10322, and you
I mean, one is positive and 0322 is vinculum. It's basically negative.
But sir, I mean, just to quickly write it, see, I mean, here what I have to do is I have to first to write it into this notation. What I mean, I have to do is I have to subtract 322 from 10,000. I have to subtract 9678 from 10,000. So I will get, okay, what is the remaining, this thing is 322. But how do you actually change it on fly, in the sense that 9 becomes 10 is okay, but then
no, actually, when you subtract something from zeros, say from 10,000 you are subtracting a smaller number, we have to always do this thing and carries one. These are not required. This will automatically work if we follow that Nikhilam Navatas and Charamam Dasata, means that the ultimate one you subtract from 10. So it becomes 2. 8 becomes 2.
Okay.
And all others, don't have to consider, don't have to put one, I put 1 as if it is, it become now 10, it become 12, subtract 7 from 12, all these kind of whatever subtracting procedure you have, subtraction you have learned.
Yes,
You don't
yes.
have to apply that. It will
Right.
automatically apply it. If you follow that Nikhilam Navata, when all are from 9 and last one from 10, if you follow that, it will automatically it will be taken care of. That is the beauty of it.
So from 10, minus 8 is 2, and 9 minus 7 is 2, 9 minus 6 is 3. Okay, sir.
9 minus 9 is 0.
All right.
Anybody, just you, that's what I told you, that all carry paper and pencil. You also practice side by side.
Right,
You
sir.
can just practice side by side.
Thank you so much, sir. Thank you so
7,
much.
6, 8, 9. So 9 is subtracted from 10, so it becomes 1. But 8 is subtracted from 9, become 1. So 6 is subtracted from 9, become 3, and 7 is subtracted from 9, become 2. So 2, 3, 1, 1. So any further question?
Yeah, and
Whoever
now
asks, please kindly switch on your video also, so that I can see. So that we, as if directly you are conversing with each other. Very good, actually. Zoom is very powerful.
right,
So
I think now it is slightly clear when you explain now how 9678 is immediately written as 10322. Now it is very clear.
Yeah,
Very
yeah,
nice.
yeah.
Thank you.
And this is the beauty of, see, this is the, I told you, those are rishis. So we cannot compare with the ordinary persons. We cannot compare their mental capability. It is told that Einstein himself used 10% of his brain, but there can be rishis who can use nearly 100% of the brain. So their intuition cannot have that. So the people who can foresee that from henceforth, this will be the running mathematical framework, basically the place value system. This will be henceforth all the ages throughout Yug after Yug. This will be used. So they design such a number system which is still running. That is Rishika then one is the contribution of Rishis. So they use all kinds of things. They use this place as negative value in a particular place. -4, -4. All these are actually they can be used as if like positive things. Only thing is that we have to write plus minus in minus into minus is plus. These have to always mind. So vinculum 3 and 3 it becomes vinculum 9, whereas vinculum 3 into vinculum 3 becomes positive 9. So these kind of things you have to make the formula, so that will work. So should I go to the next slide? You just know, you can note down. You can please note down, and so you can practice this. You can put your own numbers, and you can practice own numbers. Sometimes I will show you, because it may take some time. I'll like I can do it. So, or later I'll prepare and I'll show you that how mixture of these two also is also possible. I will have to also practice one in properly. I will do it. So not now, not in hurry. Should I proceed for the next slide?
Sir, excuse me.
Yeah.
So what you told is clear. Only one thing I want to confirm is that the first number will always be 1.
Oh no.
I mean, in the vernacular form.
Yeah. I'm changing it slightly. Yeah.
Okay.
So what do you do here? I'm subtracting from, basically it should be 4. It should be how much? You tell me. Ekadhikana purvena. When you are converting from normal number to vinculum,
Right.
ekadhikana purvena becomes 3.
Okay.
So it becomes 2, and this becomes
5.
5.
Okay. So I have to add 1 each time. Okay.
Converting from this thing. So this becomes 4. Here it becomes 3. Here here it becomes 5. Accordingly, this gets modified to 4, 3, 14. I'm correct?
Right, sir. Right.
And this becomes also 14. Obviously, it becomes 14. And this, when you convert, it eco nulleno becomes 30. Okay, now? Is it correct?
Yes, sir. So this last row, I mean,
Yeah, one is missing.
added it or
What one?
sir, I'm saying this last row, have you just added it? I mean, simply as we add, or you have done some calculation? I mean, some Vedic this thing?
And she added 3, 2 plus 1, 3, 3, 3, 3, 3 6,
Okay,
6 to
okay.
8.
Like we usually add.
2 plus 1, 3, 3, 3, 3, 6, and 6.
Okay, okay,
3,
okay.
3, 6, 4, 4, 6, 8. It becomes 14. And 1 is carry. 1 is carry, but it means actually basically 1, not 1, it's a minus 1. 1 is carrying all and minus, of course, so no
Right.
problem. So 1 plus 2, 3, and again 3, 6 it becomes. So this
Right.
becomes 6, 4, 6, 8. All this addition of 0, 3, 2, 2, 2, 3, 1, 1, 1, 4, 3, 3, and 2, 4, 0, 1. Had it been positive also, the same thing, the result will come. 6, 4, 6, 8.
Okay.
And then these are all positive. 4, 3, 2, 5, non-vinculum becomes 14. So 14 and this 6, 4, 6, 8 in vinculum becomes 13. Eko nulleno purveno. And see 3 becomes 6 becomes 6 vinculum becomes 3, 4 vinculum becomes 5, 6 vinculum becomes 3, Nikhilam Navatas, and Charamam Dasata, 8 vinculum becomes the last, so it becomes from 10, it becomes 2.
Right, sir. Right.
So what about like a 3-digit number like 127? It will be 273 or 1873?
127.
Yes, sir.
It is 1, 3, and vinculum 3. As I told, about 1, 2, you don't have to do anything. Last is 7. So 7, you write it. 7 you convert to vinculum, and 2 becomes 3. Ekadhikana. So it becomes. Should I show you? Yes, I will. Acha. Let me go to slide show from current slide. You are telling now, this I'll tell you. Interruption. Okay. So you told 127.
Yes, sir.
Okay. Is equal to, I do 1, 3, and 3 vinculum.
Okay, sir. Understood. Thank you, sir.
Okay, so we have to use it only for the digit where it is more than 5, greater than 5.
More than 5.
Okay.
Even 5, even or sometimes if it is inside, you can even make it 5 as a vinculum 4. But if 5 is in the last, so becomes it will be 5 will remain as vinculum 5. That is the thing. The last one you need not do. Therefore I had written greater than or equal to 5. So yes, inside it is 5. Then you can do also make it as a pointer. Make it as a vinculum.
Okay.
Okay.
Right.
It is clear now. We'll have practice. No problem. There will be practice sessions. So let me go through all these procedures once, and we'll come back. Even we can come back to any slide. Anybody has any doubt? My idea is not only you should learn, but you should reach to such a stage that you will be able to teach others. Otherwise, the propagation will not be there. But you can be also a master student. That way, you can also teach others, and they can also teach. These are very easy, and only thing is that we are not taught to think in this particular way. That was the thing. Had it been taught from childhood that we could have thought in that particular this way, and this would have been like easy, like what is Bengali called jolbhat, means like mundane thing, or eat rice and something like rice and water. We call it in Bengali. Now, now I switch over to multiplication. I'll come back to addition again and again, and vinculum, of course. See the patterns like this. So it is a multiplication near. Achha, you had been circulated one prospectus with all these things. No, I added some things actually. Earlier, what prospectus you must have circulated, you got it earlier. There are some additions. As I found that to link all these things, certain concepts are required, like vinculum, so on. I didn't elaborate it earlier. So tell me some, session-wise, some addition and extension and or deletion, whatever it is. And according to the reaction of the people who are students, which you are doing, I will slightly modify and I can go accordingly in a particular speed. Now, the multiplication of this thought, 97 by into 93 or 987 into 988, all these kind of things can be handled. How? Now, base, there one first have to choose the base. What is base? Base is the nearest power of 10. Say, for example, this 97 and 93, it becomes the base is 100. So 97 is how much short from 100? Is 03. Here we are not using explicitly vinculum. We could have done in a way vinculum, but here the application is like this. 97 is you write it in the side, we write minus 03, and 93 we write minus 07. And the result will be very easy. You subtract, cross subtraction. Either you subtract one and the same thing, of course, 97 minus 7 or 93 minus 03 becomes 90. And 03 into 07 becomes 21. So here the result is 9021, as you just said. You don't have to do 7 multiplied by 93 and then do this thing, shift it, and all these things are not required. Similarly, higher bases. 997 minus, it becomes 003. Purposefully, I wrote that when I took the same thing as 3 and 7, it could be different. But I want to show that how it is getting started, transformed easily from one to another. You are adding extra 9s and extra zeros. That's all here. 997 becomes minus 003. You have to mind it. You have to write the equal numbers of zeros, required numbers of zeros. Same to match this number of digits 003, 007. Here it becomes 021. Yeah, 997, as I did earlier in this case, becomes 990. Here it becomes 999, 990. And again, it was 0003, 007, 0021, keeping same number of digits. It is seen that increasing more 9s in the whole multiplication becomes resulting more addition of 9s in the first part and number of zeros in the second part. What is the explanation? Explanation is very easy. Explanation is that we express is like this: n minus a, where n is actually the base. N minus a into n minus b is equal to n into n minus a minus b plus ab. Is it correct? Is it okay? N square minus an minus bn plus ab. We express it this way. So this basically this part is shifting towards left, become multiplication by n is base, and this is basically n minus. It is already n minus a. This is already n minus b. So when you again subtract, it becomes n minus a minus b. Understood? And this becomes That to everybody? How it is happening? Clear? Any reaction?
Yeah, it's, I mean, only thing is we'll have to practice. Few numbers we'll have to practice, then only we'll understand.
So, tell me what you have in mind.
No, just give few numbers so that we immediately do and understand. That's it.
Should I give some more numbers?
Yeah, Namaste ji, Ramakrishna here. You're able to hear?
Please put your video in on also. Video on also.
Yeah. Namaste ji. You're able to?
Namaste, namaste. No, here, but you please make your video on so that I can see you also.
Yes, I switched on.
Oh, acha, let me see. Oh, acha. Yeah, I see you now. Ramakrishna.
Yeah. No, here let us take one number, which is like 12. No. 12 into.
No. 12 into?
12 into 9997.
12 into 9997.
Yeah.
No, this should be by some other method.
Yeah.
Because one is very less, no? 12 is very less.
Yeah, that's why I wanted to ask.
I'll see you. I'll show you. This is for another Tirjagabham. This will be
Sure.
there.
Thank you. Yeah.
Presently, this particular I'm confined to all. See, I can change only as you told. I can give you some example. I'll do it later. No problem. Just an example I've given. Suppose it had been say 987. Here it could be 013. Suppose it would be 987. I say 983. It becomes 017, and you have to do again multiply by 17 into 13. It will be something here. Put that here. Okay. Had it been 13 and 17, you could have 13 into 17, same thing. And 917 minus again this 17 become 990 again. It can be 0 like this. So you can easily practice it, and you can easily see that it's all working.
Gautamji, I have a small doubt. I mean, I'll put on a video also.
Okay.
I'm Babu here. See,
Okay.
just now you said 987. 987 becomes 98013 at the end. So again, if you have some other number, say, which comes at 017, in the example that you have shown, 3 into 7, 21 was very simple. But when it comes to 13 and 17, multiplication would again become a complicated one.
There actually would have to do two steps.
Okay. Thank
17 into 13, you can make it in 2 steps. You can follow any method. Sometimes it becomes actually that
again 10 into 3,
sideline.
10
It becomes
right.
Inside. You complete that one and put it here.
Right.
It happens.
Right.
You have to 1 or 2 steps. We'll see, go to that.
Right.
Past time, let me go to the concept.
Yeah.
We'll again go to the different exercises. You can do design exercise, and I will tell you that which method will be best for which particular one.
Right. Thank you.
So it is just a bird's eye view, you can say, and understanding plus not only bird's eye view. I'm not showing the PowerPoint presentation and going through very fast. I'm halting and asking for reactions and so on. So okay, this is about multiplication here and base, but below it.
Namaste.
Namaste.
Actually, I'm Sugnan.
You
are able to see me?
Yes.
Yeah. See, in the second this thing column, that is in the first thing, 9990021, that is written. Okay. The second, when it comes to the next one, 99990, how is it written? That 99990 that I just want to
understand. Right. See, it was 99997, and it was 0007 minus 0007. So it's subtracted, no cross subtraction. So
Okay. Yeah.
This
Yeah.
one was subtracted from this one.
Okay.
So this becomes n minus a minus b. This is already
Okay.
n minus a, and this is b. So n minus a minus b becomes this one. Or this is already n minus b, and this is a. 3 is a. So n minus b minus a. So this becomes n minus a minus b. So that is right.
Okay. Yeah.
Cross
Got it.
subtraction.
Yeah. Got it.
And
Thank
this
you.
is a into b. That is right.
Thank you.
I kept it easy so that it's easy to understand. Later on, we can complicate. Sometimes it becomes a carry. Okay, that carry has to be added here. Yes, if it is sometimes more than, it is such a number that sorry, it becomes more than this. It needs a carry. Carry will be there and it will be added. It can happen.
Okay. Got it. Thank you.
Now I come to case where
Excuse me, 1 second. For
should I go to
120,
yes. Yes, please.
yeah, Dr. Mukherjee garu, this 127 becomes 133, isn't it? 133 and 3 with minus, correct?
Which one?
127.
127, yes.
Yeah, 127 example, what you discussed,
Vinculum, yeah.
Yeah, so 127. So 7 is 10 minus 7 is 3. So you put 3 there. Correct?
Yeah.
So, but from 1 to how will you make 1 3 as per the rule? What is the rule there?
Ekadhiko no purvena.
Acha, ekadik purvena. Okay.
And you convert back to normal number, it is eko nunne no purvena. You reduced by 1.
Acha, okay, fine. Yeah, thank you.
So I'll go to the next one where it is also near the base, but it's above base. How it is? Say it is like this 107 into 103, 1017, 112, 50, 13, 10123 into 105 and so on. So 103 into 107 example. It becomes plus 3. How much is base in again 100? It is plus 03 plus 07. So it becomes again this plus this, so 110. Either you or this plus this is also 110. And again multiply this by this, so it becomes 21. So this is 11021. Okay. Similarly, when it becomes higher basis, base is 1,000, base is 10,000. Same numbers are used, so it becomes like this. 1010, the 1007 plus 003, 1010, and this becomes 021. Here it is 10010 and 0021. Have you seen that increasing more number of zeros in this case will be in the multiplicand will become in the first part it will be number of zeros will increase, and the second part also number of zeros will increase. Again, the algebraic expression is very simple. One is n plus a, another is n plus b, and what you do in this first part, you have to do n plus a plus b, and it is shifted to this many digits, means you are multiplied by n, means base is whatever the base is, this n is the base. This number of shifting is there, and then a finally a into b in the second part. But number of keeping the number of zeros intact, 007 into 003 becomes 021 and so on. It's like this. Is it clear? I think it was clear.
Yes, it is clear.
Here I give a slightly bigger number. Let me take 10123 and 105. Let me strike it. Okay. Now, sometimes you tell me 10123. How much should I write here? Plus Anyone?
1, 2, 3.
1, 2,
Huh?
1, 2, 3.
No. Any other answer?
Zero, zero, 1, 2, 3.
Any other? No. Any other answer? Somebody told 1, 2, 3. Somebody told 0, 0, 1, 2, 3. Nobody told in between. Huh? It should be 0, 1, 2, 3.
Okay, 0, 1, 2, 3.
Yeah. So appropriate number of 0, 0 you have to give. Let me keep small, no problem. I can keep it bigger, but keeping. Let me see in the next class I can do it. So let's slightly practice more, because it will be involve some carry, and in one go I don't want to do all this. So becomes how much?
0005.
005.
Exactly, 0005. So if you write the appropriate, see it is basic 10,000, and here it is 1 plus 4 digits. So it is near about, either earlier example it was negative from the base, it is positive from the base. But always in case of negative, the number of total digits 999 something. So we have to do four digits in that case. So and here it is above 10, but although it is showing 5 digits here, but actually 1 plus 4 digits. Here also you have to make 4 digits to make it up. Now tell me. First part is how much?
10128.
Exactly. Thank you. 10128. Here, what do you think?
Zero, 1, 2, 8.
How much?
0, 1, 2, 8. 0, 1, 2, 8.
615.
Huh?
Six one five.
0615.
Exactly. Thank you. Yes.
Okay.
Okay.
0615. Okay.
We do not like the
Oh.
plus here. It is a result. So no plus here.
0615. Okay. I do not get it.
But here it's
0615.
becoming little difficult now. 1, 2, 3.
Oh, yeah. Okay. Okay. Oh, okay.
You know, 1, 2, 3 and into 5, all are less than 5, no? All are not more than 5 at least.
Multiplication, you have to imagine and do it now. It's 3 number versus 1 number.
Here, this one small, as I told, the 5 into 5 table, up to that much you must.
Yeah. That's
Otherwise, it is not that you don't have to do. And moreover, I'm telling that we do not think that it is a replacement of the current procedure that we learned from childhood. Current procedure is going on. It is the addition of this thing. Wherever we switch over to the normal our practice procedure already and do it, no problem. There is no harm in that.
In India, usually 20 tables are known, but this is 123 table into 5.
No, it's not table. 1, 2, 3 into 5. Don't have to do table. 5 into 3.
Yeah. Somebody has to
5
do
into 3 is
mental.
5 and carry is 1. 5 into 2
I know.
carry 1 and this one.
Normally in our childhood, we are taught up to 20. 16 into 16, I'll say 256 straight away without doing any multiplication. Whereas in 123.
So here with single, I'm talking of single digit table. 5 into 5 is the maximum required. That's what I was saying.
Yeah.
Acha. So this is the procedure is clear. Thus,
Sir, here in the algebraic explanation in this slide, it's written here in the last line. Here cross subtraction is n plus a plus b. Shouldn't it be cross addition?
Oh, yes, yes. I just copy that. Is a,
Okay, sir.
I'm sorry. Thank you. Yes, because it is a copy and paste. Yeah, that much. Yes. Thank you.
Copy
So that
paste problem.
this is good actually. So that I also get some enthusiasm that people are
Watching
also
it.
watching it minutely.
Participating
Broad
actively.
addition is like this, and AB and multiplication is same part. Okay, clear? Should I proceed should I proceed for the next one?
Yes.
Here it is a mixed one. Multiplication here is base, but it's a mixed one. It is 97 into 103, 97 into 1012, 9995 into 10, like this. So take the example. Base is defined as a power of 10, nearest power of 10. So it is again this 100. So 93 is minus 07, whereas 107 is plus 07. So when we add these things, either you can do 93 plus 07, or it is 107 minus 07, means 100. And here it is multiplication of these two and this thing becomes vinculum 49. You have to mind it. Negative of that. And finally, when it becomes
Repeat it, please.
10049, here you have shown that in our term, current term, it is expression of that, but actually expert in vinculum immediately will make it it becomes, result becomes 10049 vinculum, becomes nichilum econunneno. So 100 becomes 99, and 49 nichilum novatus means 4 becomes subtracted from 9, becomes 5, and 9 gets subtracted from 10, becomes 1, 9951. Clear?
Just one thing. Excuse me.
Yeah, please.
So Yagyesh this side. So just one thing that in that, no sir, I think the slide has changed. I mean,
yeah.
So sir, this means that whenever we subtract, like we have written these two things as 93 minus 07 and written 7 plus 07. So when so even in the previous this thing what I mean, which we have been doing, we were actually just simply either cross subtracting or cross adding, but here we are doing both the things. So I mean, we should
therefore you have to carry the sign also now.
Okay. So the concept is like we have to do it with the sign. Whatever sign is there, we have to do it accordingly.
It was earlier. It was carrying this minus symbol. Therefore, you are subtracting. It was carrying that positive symbol. Therefore, you are adding, like this. Okay.
So here one is plus and one is minus. So
accordingly, you have to do.
Thank you, sir.
Yes. And accordingly, this also minus plus, so it becomes vinculum. 7 into 7 is 49. Vinculum 49. Becomes like
right. So then we can convert it to the normal this thing.
Normal one. So here also you see 1013 and becomes plus 013, and 993 becomes minus 007. So it becomes 1006. Either it will always same. It will be always same, because basically we are working with a particular base, either plus or minus. So we cannot cannot be other way around. So 1013 minus 007 becomes 1006, or 993 plus 013 becomes 1006, and then becomes 091. Okay, and becomes 1005 909. This is Nikhilam Navatas. 0 also have to make. 0 also you have to convert. 0 becomes 9, 9 becomes 0, and 1 becomes Charamam Dasata, becomes 9. So result becomes this. And here it is 999 0021 9979 9995 becomes Nunneno, 1 equal Nunneno. Expression is this: n plus a into n minus b, n into n plus a minus b minus a. Here you see that if the number of nines and zeros are in added, becomes nines, becomes this first part more nines are added, and the second part more zeros in that. Doesn't matter. You could have done say 1 crore 13 and 9999 similar same kind of base and 3. The result also would have been 1 crore 6 and this. Anything like that. Accordingly, it will be also changed. It is also changed. So this becomes general. Other is in our conventional way, we have to get lot of brain work from getting from one to another. So here you have to do much less brain work. You are just shifting some shifting, some addition, small addition, some small subtraction. That's all. So brain work is much reduced here. Is it clear? Clear to everybody? Everyone?
Yes.
Yes, so we need little practice for this.
Yeah. So we will have practice sessions, bigger practice sessions there. I will request all of you. Now the session is going to end after some time. You design on this line your own problems, and either you solve it or we can keep it for discussion. You design your interesting problem so that we can take it and we can discuss here, so that all others get benefited.
If the number is closer to the base of 1000 or 10,000, it seems to be easy. But if it is far away from that, I think it may be a little complicated.
For that, some other procedure has to be there. So
one more deduction is required.
There will be more procedures, so we'll have to go to that. Let me now better we go to the next slide. I think let us see a sub base. Here with this concept, I will maybe that time will be up by this way. See now it, as you told, you already demanded this like 483 into 497. What do we do? Both are above below a sub base. Here the consider the base as 1000, but sub base is 500. Or alternatively, also it could have done base 100 and sub base 500. Procedure should be different. How it is different? Suppose I consider first base 1000. 483 minus, it becomes sub base is 500 in both cases. So sub base, from sub base, how much it is less? Minus 017. It is minus, you write minus 017. 497, we write minus 003. We multiply. So it becomes 051. Again, same procedure. 483 minus 003, 480, or 497 minus this minus 17, it becomes 480. The same way. But because this sub base is half of that 1000 actual base, we make it half. Result becomes 2400151. So we have to do that in this n procedure. This particular algebraic expression or this one, we have to little modify. Well, this one, for example, here we have to little modify. We have to put half n, and how it becomes. We finally will see that there one half is there somewhere, and we have to make that. Finally, you have to half it, and it becomes this result. Or other way, same result will get with base 100. 483 is here. See, base is 100, so you have to write not 017, but 7, only 17, only 17. Minus 17, minus 03. 480 becomes, and 51 I do. But in this case, I have to multiply it by 5. So we get back that extra 0 here. So in both cases, the result is obviously same. Clear? Any reaction? Again, it could some example can be there. In one is less, one is more than a sub base. It could be.
Any suggestion on how to choose the base, either 1000 or 100? Is it all by experience, or how do we do it?
Experience here, base is in case of this kind of things, as I told, this both the bases can be there. I can choose either 1000 or 100. Accordingly, you have to do.
To make it
either
simple,
you multiply by
to make
5
it
or
simple, which will be better, either choosing the higher one or lower one?
see here it is 500. Had it been say 600 something, there actually the 100 base would have been better. 1000 base or will not have been applied. It will be bigger numbers.
Further multiplication should not get complicated.
Huh?
No, that base choosing will be important, because otherwise you have to again
Yes.
multiply some big numbers.
See, I could have could have chosen sub base 600, for example.
Yeah,
Now this 600, it would have been minus 117, minus 103, because it is 600 is the sub base.
Yes, sir.
Again, I will write big multiplication to do, and you do something.
So that will come by experience, probably.
Yeah. That will come by experience. That intuition will be developed actually.
Yeah.
So you will gain more expertise with the number system itself, which earlier our rishis did.
The more we practice, the better we become, probably.
Pardon me?
The more we practice, the better we will become.
Yes. More you practice, becomes expert, and plus different your intuition gets developed between different procedure choice also. So that way it will become general multiplication. So actually this becomes how much time you are left. It is like this. Now we come to general multiplication. I will again come back, no problem. Then Nikhilam, those actually you are called Nikhilam method. These all are called Nikhilam, Navatas, Charama, Dasata kind of thing. Multiplication near a base. Now the formula is changed. It is Urdho Tirjogabhyam. So it is like this: 10A plus B into 10C plus D becomes 100 AC plus 10 AD plus BC plus BD. See, earlier earlier also you had two lines, no? 5 into 43 becomes this line, 2 into 43 becomes this line, and add. But here it is slightly different.
This is you are taking in next example.
I am taking next example. I will cover it in detail. I just started it. Now
we are already.
How much time we are having now? It's about to near the end. So this I'm giving you the food for thought. It is like this. First you do 3 into 5, 15. I write the carry below. It becomes 15. Now we do 5 into 4 plus 2 into 3. Becomes how much? 5 into 4 is 20. 2 into 3 is 6. 26. 6 I write here. and 2 I carry, it is below and left because it is higher value, higher positional value. 4 into 2 is 8. So it becomes 8. On the top, it becomes looks like 865, and below it is 21. But it is not actually like when you add it 5, 6 plus 1, 7, to 8 plus 2 is 10. 1075. I give more example with bigger one. Bigger ones again. 100A plus 10B plus C into 100P plus 10Q plus R becomes 10,000 AP plus 1,000 AQ plus BP, cross like this one. Again, three kind of process, this into this into this into this. And they get BR plus last 2 digits, this cross, and they get straight CR. 314 into 358. Here actually, if we get bigger numbers, say 800 or something like that, we can always convert into vinculums. So ultimately, all becomes less. Sometimes you get subtracted. Here, instead of adding like this, you get also subtracted. It becomes the number becomes less. So here 4 into 2 is 8. Tomorrow you actually will start with this. So you just have it food for thought. 1 into 2 plus 4 into 5 is 22. 3 into 2 plus 1 into 5 plus 4 into 3. Like this. 3 into 5, 1 into 3. It becomes this. And 3 into 3, 9. We add, gets like this. In first go, you totally are saying you are puzzled by seeing this, some of you. But it will be with practice, it will be very easy also. Maybe that tomorrow we'll take example, we'll broaden it actually. I mean, totally in a fresh slide, we'll write all these things. We'll broaden it. And in a broad situation, I'll write. And basically the algebra behind this is like this. Algebra behind is this. See here also, with our conventional mathematics, there could have been 3 rows. One you write 314 into 2, 1 row. 314 into 5, another row. 314 into 3, another row. Then you add, isn't it? That was the conventional method. Here in mathematics, you get only 2. And not only that, in the conventional way, you do not have any concept of vinculum. So if it is all are bigger than 5, say 7, 8, 9, you have to all multiply that big numbers should multiply. Here you have to do. Here you immediately convert into vinculums, follow the procedure, and this cross will be very easy. Sometimes it will be subtracted instead of all addition. Sometimes you will get subtraction also. In subtracting, you will get very less number sometimes, and then finally it will be very manageable number. You will get it like that. So should we close or here is even bigger? See, more numbers are added, it will be bigger and bigger. It is after that we'll go to. So let me stop here. Any question?
It's very interesting and a lot of brain work initially. Maybe it'll lessen later. Maybe initially there is a lot of brain work because you'll have to understand the concept.
Yeah.
And later on, it will be less of brain work.
Yes. Yeah. Switching over to basically, we are not taught from childhood.
Basically, yes.
We are only one procedure is taught from our childhood.
Right. Yes.
We are used to the other one. Right now, it looks little complicated, but I think as we practice, it will become easier.
Yeah.
Mahadaya Sarvebhyo Namo Namaha. So where can we get that book? How can we get it?
In the Amazon, I'll send a link to Amazon. I think I have the link. This you are talking of this book, na?
Vedic mathematics book by
Bharati Krishna Tirthaji. He is actually Shankaracharya of Puri. Puri Mount is called what? I'm not getting immediately. I'm remembering. Puri.
is it available in Amazon?
Yes, it is Amazon. You just search it.
Thank you. Dhanyawada.
And I have also shared one, I shared one a text actually. That's also basically from this. It is also taken from the book, but not fully. Partly it is from that book. But it is the part of the book has been taken from that. And there are also some examples. You can go through that also. I think few days back it was shared in this particular Sanaatana Dharma.
So at present we require a simple book so that later on we can have complicated some.
This book is simple and from the beginning. Actually, I had this book in for some time. Sometimes we find it difficult, as if somebody would have make me understand like this. But gradually, when I went through different things, and it becomes easy. Actually, in one go, the book may be feeling difficult, but later on it will be easier. And of course, I'm giving whatever I have gathered. I will be discussing in these 5 sessions. So I think at least those things can be understandable by everybody. Any other question?
Okay. It's a very good interactive session, right from the beginning to the end. So there is no separate question answers required. So very well prepared. A lot of work has been done because mathematics doing on PPT needs more time, special care and more time so that it comes out correctly. So now let us do Prarthana and then.
Now I want to ask you one question that I expected that some students also will participate. Were there some students along with some of our participants? Some children? And anyone had any children along with understanding these things?
Anybody, any child who is 6th standard or above listening to this? If so, raise hand or unmute and say yes. CB Lakshmi garu, you want to say something?
Yeah, actually, I would like to interact with Dr. Gautam Mukherjee later. I still have some doubts. I just listed out. I talked to him since he has already given the contact number.
Okay.
So, which one? Which one?
She says she will interact with you separately.
Okay, separately. Yeah.
And I think today students are not there.
Acha.
Probably they may get interested tomorrow.
Yes.
Okay, let us do Prarthana and then
yes.
do Janaganamana. Okay. CC Babu garu, are you there?
I am there.
Okay. I will do Prarthana and then we will have Janaganamana.
Okay.
Prabhakar sir is there.
Is there? Okay.
Yeah.
Can you do Prarthana, please? Oh, yeah.
You want to, you can do it. I don't mind. Like to do it, Babu? Would you like to do or shall I do?
Do it. No problem.
सहनावतु सहनौ भुनक्तु सह वीर्यङ्करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः सत्यं वद धर्मं चर सर्वे जनाः सुखिनो भवन्तु गुरु ब्रह्मा गुरु विष्णु गुरुदेवो महेश्वरः गुरु साक्षात् परम ब्रह्म तस्मै श्री गुरवे नमः सर्वं श्री कृष्णार्पणमस्तु
Okay, ధన్యవాదాలు. Let us do Janaganamana. CC Babu garu. Let us all stand up.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्ज्वल जलधि तरंगा तव शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद जय हिंद जय हिंद
Thank you. Thank you. I think we had enough interaction. Now we will close.
Yeah.